All right. Let's look at this. It's going to combine quite a bit of things that we've been over so far. Okay, the census wants to estimate the average income from Georgia residents between the ages of 25 and 35. After randomly selecting 100 respondents in that age category, the mean income was found to be 35,000. All right, so that's our mean income, 35,000. So that'll be X bar. So X bar is 35,000. Okay. Now, we have a standard deviation of 5,700. Okay. We want to find and we know the sample size. We took the first 100 people, so that's our N. So the first thing we're going to do is find a 95% confidence interval. Okay. So we're trying to figure out without taking all of the people in Georgia between this age group and looking at their incomes, we're trying to get a range that'll tell us what their average income is. Okay, so to do this, the first thing we're going to do is going to come up with our E value, our maximum error. So we're at 95%, so we know that for the 95%, we're going to use 1.96. So we'll take 1.96, okay, and then we'll take our standard deviation, and we're going to divide that by our sample size square root of our sample size of 100. All right, so when we do that, we come up with $1,117.20. All right, now I'm going to go ahead and round this to a whole number since our standard deviation is a whole number, so we're going to use 1,117. Okay, so that's our maximum error. So what we'll do is we'll take that to find our true mean. Okay, we'll take the 35,000 and we'll subtract for the low end, and we're going to add for the high end. All right, so here we end up with 33,883 for the low and 36,117 for the high. So that means that we're 95% confident that the true mean, or the true average for 25 to 35-year-olds in the state of Georgia, is somewhere between 33,883 and 36,117. Now, in this problem, we were also asked an additional question. So look down here, it says, if the census wants to estimate the average income of Georgians aged 25 to 30 to be within $2,000. Say it costs too much to go get 100 people, but if we're within $2,000, we're okay. Let's see how we would come up with the sample size we need for that. Okay, so we're going to use some of the previous information. Okay, we know that N is the question. We don't know what N. We don't know our sample size, but we know standard deviation to be 5,700. Okay, we know that we're still going to be 95% confident, so we're still going to use the 1.96. Okay, and we want our error to be 2,000. All right, so for this, we'll take N, and it's going to set it equal to 1.96. Okay, now again, I'm using the formula. I guess I should write this formula out, but hopefully you have this in your notes already. Z alpha sub 2 times sigma, which is our standard deviation, divided by E, and we square all that. So we'll take 1.96 times the 5,700. Okay, and we're going to divide that by 2,000. Okay, then we're going to square it. Now when we do this, we should come up with a number close to 32. Alright, so we end up with 31.2 to one decimal place. We can't have less than a person. So what we'll do is, remember, sample size, we're going to round up. So our sample size would be 32. So if we're comfortable with it being within $2,000 instead of the $1,117 range, we can just go get 32 people and come up with our confidence interval.